23rd of April 2010. We're at Huffman Labs, and we're going to have Mr. Huffman here walk us through the environmental chamber. Go ahead, sir.
Okay, what we have is an incubator that we're temperature controlling to a temperature of 52 degrees C with a tolerance of plus or minus 2 degrees C, both in variation in time and space within the oven. We verified this by measuring air temperature in various locations, and a surrogate of samples we used sand, fairly coarse sand, placed thermocouples in that, and those are actually far less, as you would expect, less variable in temperature during time than the air is because of the thermal mass of them. So the samples are going to be more stable even than the air in terms of temperature fluctuation. So this is the primary, this incubator oven is, I'd call it the primary controller of the temperature. The other parameter, environmental parameter that we control is the humidity, specifically the dew point that we produce. We have two water heated humidifiers. We have air coming through this. We call it the pre-humidifier, on the order of 10 to 12 liters per minute. This first pre-humidifier is heated to roughly 30 degrees C, and that is just both to make this last a little longer, the final humidifier that is at 37 degrees C, or our desired dew point, and also helps to ensure saturation. We're not putting dry air directly in here. We're putting air in here that's already very humid, and so it further ensures saturation of the air coming out. And then we have both to prevent condensation. Without any heating on the transfer tube, it would all condense out at room temperature into a liquid and pour into the oven. So we've placed a heater controlled by a rheostat that we are keeping at roughly 70 degrees C, and it additionally, to preventing any condensation at this point, it's heating the air. We've measured the air exit here, right at the exit from here, and it's on the order of 47 degrees C. So it's entering the oven within 5 degrees C of our desired temperature, which helps stabilize the oven temperature, because there's not a drastic temperature change and heating going on with the air that's entering it. The flow rates that we're using, if we assume an exponential dilution of the volume of air in the incubator, which I believe when it's full of the samples and bottles, we've calculated to be about 45 liters, and so there's an air exchange, or 95% air exchange every 10 to 15 minutes. We have a fan within the oven, as well as the distribution hose. We have this is where the humidified and heated air comes in to the furnace, and then it enters this ring at the bottom of the furnace that has a series of 1/8-inch holes drilled 3 inches apart around the ring. We grossly measured the flow out of each of these to be even. In other words, there's not significantly more flow on this end as there is in this end because of the loop design. It goes into a T and it's going out like that, not just going to an end, which would tend to produce more flow out of the initial ones. And again, that's not even terribly critical, I don't think, but it's good to start out with that evenly. To stir the air within the unit, we have an electric fan that is it's blowing air at a slight angle down from the front of the furnace here at a rate of about 12 to 13 feet per second. We will be arranging the bottles so there's no bottles directly being blown on, both for the sake of fear of blowing the compound out of the jar, and we don't want something directly in the wind field, and the rest of them aren't. So for consistency, we'll have a gap here where it's primarily blowing, and a gap right behind it also.
And the jars are going to be opened?
And all the jars will be opened. We've arranged, we've designed an arrangement of the samples where we have the 4 different types: the untreated sand, the treated sand, an empty bottle, and an empty bottle with the treatment in it. And those are going to be staggered and alternated throughout the oven. So if there is any variability across the oven, we hope to see that.
Can you touch on the temperature controls for me, please?
Yes, the temperature controls. We have several thermocouples routed into the furnace. Some of them are only for monitoring the temperature. Some of them are temperature feedback control. And actually, the temperature of the oven is not a temperature feedback, correct?
Right.
It is a voltage that has been determined empirically under these conditions that we set on this variac, and we've observed that it maintains this 4 degree C span at this setting, at these conditions. More critical to temperature control, or it's more difficult to control parameters, the humidity. So we do have a temperature feedback control device for the temperature of the final humidifier, which we use a set point of 36 degrees C, so that we produce a dew point of 36 degrees C, which again we monitor. That's not perfect for various reasons, whether it may be a little sub or super saturated from that value. We can monitor in here in 2 different ways. We have a relative humidity sensor, and we have what I believe is the more reliable wet bulb, dry bulb technique, whereas right in the airfield, the wind field of this fan, we have a wet bulb and a dry bulb. The wet bulb, we have the ability to add water, and we can see the bulb and when it is wet, and take a wet bulb and dry bulb measurement and calculate the dew point from that, and see that we're getting reasonable agreement with the desired dew point and our other measurement of relative humidity.
And that'll be loaded with